Art 1, let's continue our introduction to linear perspective. So now we're focusing on two-point perspective. This is where we're using two vanishing points. Typically you want those two vanishing points to be as far away from each other as possible. So typically we place them at the ends of the paper or entirely off the paper. Now two-point perspective is where things get more interesting because we're able to draw several sides to the object rather than just drawing the front. Because if you remember from one-point perspective, you're just seeing the front and maybe the top or bottom of the object. So if we use two-point perspective, here's just some images of what they look like during the process. And if you were to draw a series of buildings, right, we can show how they recede in two different directions. We can see this side and this side. So let's go ahead and draw along with me in our notes. You're going to need your pencil, your ruler, and an eraser. So first of all, we're going to establish our horizon line just as we did for the one-point perspective. So we now have our horizon line. However, because this is two-point perspective, we're using two vanishing points. So we're going to place one here and we're going to place one over there. Let's call this VP1 and VP2. So we have vanishing point number 1, vanishing point number 2. Now, we're going to draw some lines. You don't have to measure. Okay, don't worry about measuring, but just don't draw too big. So we're going to draw a vertical line first, because typically when we draw two-point perspective, we need to start with a vertical line because we need to establish the corner of the box. So I drew a vertical line somewhere around here on the bottom right-hand side of this space. And now we're going to draw some converging lines. So I'm going to take my ruler, measured up with the vanishing point number 1, so the bottom here to VP1. We're going to draw our converging line. We're going to keep it light because we're going to do some erasing. Now we're going to also, from that bottom part of this vertical line, we're going to draw a converging line to VP2. So these two lines establish the bottom of the box. But now we need to create the top of the box. So going to the top of this vertical line, we're going to draw another converging line to VP1 and another converging line at the top to VP2. Okay, we're not done though. We need to actually establish the far edges of the box. How far do we want them to go? So we're going to make this somewhat rectangular. So I'm going to take my ruler, make sure it's lined up with this middle vertical line. I'm going to take my ruler, move it over a little bit to the left side, and we're going to draw a vertical line. Make sure these are parallel. Parallel lines are two lines or three or four. They're a series of lines that, in theory, will never meet. Those are parallel. These are parallel. If we were to have them continue off, they will never ever meet. So same thing here though, in this space here. I'm going to take my ruler, line it up with this middle line, just because I want to make sure it's parallel with the sides of this drawing here. I'm going to move over a little bit and draw a vertical line. Now we need to create the top. We're going to see the top of this box. So we're going to hop over to this edge here. We're going to line it up with VP1, draw a converging line. Keep it light because we're going to erase later. Don't know why I had a hard time saying that. Now let's go to this corner here and we're going to line up our ruler with VP2. Again, drawing a converging line. So you should see the illusion of a three-dimensional box. So I'm going to go ahead and darken in the line so it stands out. Now you can keep the converging lines for this exercise if you want. If you would like to erase it, you can do that as well. I'm just going to erase it kind of loosely, just so we don't forget how we drew it. There is our three-dimensional box created using two-point perspective. Now we're going to hop down to the eye levels. So when we're drawing with linear perspective, we want to draw what we think we know. However, we need to actually draw what we would see from that specific viewpoint. And again, linear perspective allows us to do that. So is this how we draw a table? We know this is incorrect because this is supposed to be the top and the sides of the table, but we know tables don't actually look like that. This is correct, right? You see the top, the sides, and we even see the sides of the legs of the table, right? This looks a bit more believable. Is that how you draw a house? No, this is the house drawn using linear perspective, right? This is what we would see in real life. This is also incorrect. Often my students make a mistake and they don't draw the vertical lines parallel with each other, right? Notice parallel, parallel, parallel. That is not parallel because if we take these two lines, they're eventually going to meet up. Now again, depending on the viewpoint, you're going to see different parts of objects. And you can see if we were to take a box and we rotated it, you would see different viewpoints. So here we are. This is what we're going to be filling out. So we always have to consider the eye level when we're drawing in linear perspective. We're going to start with the bird's eye view, which is above eye level. Then we're going to move into eye level. And then we're going to move into worm's eye view, which is below eye level. So make sure you're following along with me. So in this space here, we're going to write bird's eye view. And what is the definition of a bird's eye view? This is when you're viewing the object from above. Imagine you're a bird flying in the sky, right? You're viewing from above. So what you can see are the sides and the top of the object. So this would be bird's eye view. We can see the front of the box and the top of the box. If we were to draw actually what this person is viewing, because again, they're above the object, their eye line would line up something here and somewhere there, right? This is their area that they can see. Now, for the middle, this is eye level, like true eye level. So we only see the front of the box. So what is the definition? This is where you're viewing the object at the same level as your eyes. So true eye level, we wouldn't see the top or bottom. We would only see the front. You would only see the front. Now for the bottom one, this is worm's eye view. Imagine you're a worm crawling on the ground. If you look at this box, you'll see the front and the bottom. So let's draw that as well for our little guy here. So we would see the bottom and the front. That's all we would see. So the definition, this is when you're viewing the object from below, right? You're a worm, you're crawling on the ground. And what would we see? We would see the sides and the bottom. You know, the underneath area. So I want to illustrate using this little painting here. Okay, so this is a little painting I made. Now, this is true eye level. This is eye level with the document camera. We can't see any part of it. But if I tilt it, this becomes bird's eye view. The document camera is looking down at this object. You can see the top and the side. Now, if I tilt it up this way, this becomes worm's eye view, where we see the front and the underneath or the bottom. So make sure you have those notes copied, and let's look at a few other things about linear perspective, because when you really get into linear perspective, things get interesting. So can you draw circles in linear perspective? Yes, you can. I will teach you later how to draw circles. So yes, we're going to start with drawing boxes, but I'll show you how to draw circles in linear perspective, and they're called an ellipse. So just to show you some illustrations here. Again, this illustration here has a horizon line, has a vanishing point, And you can see the converging lines that are red that were used to form the circle or the cylinder. So atmospheric perspective is what we would see using color and value. That was back to the 6 ways to create space in an artwork. Areas that are closer are darker, the areas that are farther away are lighter. This is a really cool trick. See this painting? What's this over here? What is that? So if we took this canvas and tilted it, we would see a skull. This is called anamorphic perspective. Again, it's playing with your eyesight, your eye line, your eye level, right? So viewing this painting from the front, we see this smear. Rotate it, we see a skull. Here's another example of anamorphic perspective. So this is a flat drawing, but depending on our eye level, we think it's 3D, but it's not. These two tubes are mirrors. So this is the drawings, and they're being mirrored and reflected back. And so we can actually see what's being drawn. But again, it's been stretched out. We can see anamorphic perspective often being used in murals. So here's the mural viewed from one eye view. And if you change your perspective, you're going to see different designs. So you can see how, due to the use of the lines and the placement, it changes, right? It's an optical illusion. We often see anamorphic perspective being used in those chalk art paintings that you can find on the streets sometimes. Again, from this viewpoint, we can see this. But if we were to stand over here, we would have a different view. There's also forced perspective. This is something fun you can do with your phones and your friends. It's all about the placement, right? The size, the placement, the overlapping. So this girl looks really tall, looks like she's lined up with the Eiffel Tower, but we know in real life she's not. It's an optical illusion. It makes the objects appear bigger, farther away, or closer. You can actually see forced perspective being used in the Disney parks. This is how they're able to make the buildings look taller when they actually are not. So for these buildings here located on Main Street, USA in Disneyland, the doors are the correct size. You can fit through the doors. The windows are correct. But when you look at the second level, the windows are actually a little bit smaller than they would be in real life because the buildings are actually shorter than what they actually are. We see that with the castle as well. The bottom of the castle is actually a little bit taller, and the areas above the castle become smaller. Matterhorn uses the forced perspective as well. There is 3-point perspective. Yes, you can actually draw using 3 vanishing points. Sometimes you'll see this when you're floating above a city, like when you're flying in on an airplane. And again, you can see there's a horizon line with 3 vanishing points. So that's how it would look using 3-point perspective. There's also 4-point perspective, which uses 4 vanishing points, and even 5-point perspective. This allows us to create that fisheye lens illusion. And again, once you understand linear perspective, you really just start to recognize how artists are able to create a sense of depth and space in a flat artwork. This is actually a wall piece, but again, due to the placement, use of linear perspective, it looks like there's space within this flat area. This is a scene from the movie Inception. So filmmakers also play with linear perspective. Not exactly the same way because it's a movie, but it is playing with our eye level, which is the view of the camera.